Okay, so let's make the table for Toolkit reciprocal function. We're going to use the standard values. We're going to do x versus y, and y is going to equal 1 over x. Okay, so we're going to have -2, -1, -1/2, 0, 1/2, 1, 2. I'm going to plug this x value in this formula. We're going to get y equals 1 over -2. Well, what's 1 over -2? Same thing as -1/2. It's just basic fraction notation. And then 1 over -1 is just -1. Now, what's 1 over -1/2? That's 1 divided by -1/2. Now, we got to go back to the basic arithmetic for Toolkit functions. If you don't remember the basic arithmetic, then you better review it because we need to understand it. And see, this basic arithmetic is going to evolve into basic algebra of rational functions, which is a big hang-up for students. We have to understand these rules of arithmetic so we can apply them to the algebra of rational functions, for example. Okay, 1 divided by -1/2. Now, division by, first of all, we have to understand that 1 over -1/2 means 1 divided by -1/2. And it means then, because division by a fraction is multiplication by the reciprocal, it's going to be 1 multiplied by -2 over 1, which is -2. Okay, now 0. It's undefined. Another way to write that is BNE does not exist. Since it doesn't exist, we don't use 0. We cross out 0 because there's no value, and we're just going to put a little wavy line in here instead of a bunch of big X's and cross it out. We can read what we crossed out, but it's now crossed out. We say that the 0 here is not in the domain of the function. I will find that later. In any case, there we have it. Okay, we're just trying to do the arithmetic at this point. And one thing about the arithmetic, if it's undefined, we say it's undefined and we cross it out. Okay, here we get then, okay, when x is 1/2, we get y equals 1 over 1/2, which is 1 times 2 over 1. Which is 2. And then when x equals 1, y is 1 over 1, which is 1. When x equals 2, y is 1 over 2, which is just 1/2. And there we have it. There's our table. Okay, we have these 3 values and these 3 values, but this value is excluded. Okay, that was easy, wasn't it? If you know the rules. And again, you want to know these rules. You want to remember them throughout the course because they're going to keep coming back in harder and harder context. You're going to come back in the algebra and you're going to come back in ways that you might not expect. Maybe you do, maybe you would expect. Okay, now let's do the table. The Toolkit exponential function. And of course, basic exponential function is y equals 2 to the x. Okay, start with our x values, -2, -1, 0, up, -1/2, 0, 1/2, 1, 2. Now, there are several hangups that can occur with this basic exponential function, just like you had the sort of a hang up that occurred with the basic Toolkit reciprocal function. That you couldn't evaluate it at x equals 0. Here, well, okay, if x is -2, okay, well, you just write y equals 2 to the -2 by your rule for negative exponents. That's 1 over 2 squared. That's 1/4. If you understand that rule for exponents, and you should understand both what the rule is and why it makes sense, because that was all explained, then you won't make a mistake on this. Okay. Now, what's the 2 to the -1? Well, that's one over 2 to the 1, which is 1/2. Now, what about -1/2? You got 2 to the -1/2 equals 1 over 2 to the 1/2. I think you get the powder here. Okay. But we can't calculate that. In the video on the explanation of the arithmetic for the Toolkit functions, we established that to do e to the 1/2, you have to do an infinite number of calculations, and 2 to the 1/2 is the same thing, but the calculations are even worse. The simplest number you can do the 1/2 power of is that's not an integer, it's a fraction, it's a square, a perfect square. The easiest number you could calculate the 1/2 power of, then, it isn't a perfect square of a simple fraction or an integer, is e. Any other number is even more detailed, even more complicated. Okay. And calculation goes on forever, so we cannot even in principle calculate an exact value. And for that reason, we don't use it. Okay, now here we have 2 to the 0. X equals 0, 2 to the x is 2 to the 0. Can you calculate 2 to the 0? Well, again, if you understood what we said in the arithmetic of basic functions, and if you didn't, you really need to go back and look at that again. And every time you find that there's something that you don't remember from that, you need to go back and look at it again, or look at your notes. Look at the reasons for the things we say there, okay? Then eventually you understand it well enough that you don't have to even stop and think hard about it. Okay, so anyhow, 2 to the 0 has to be 1. Remember, 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 3rd is 2, 2 to the 1st is 2. So 2 to the 0 has got to be 1/2 of 2, which is 1, and then you can negative exponents. You need to understand that. So that's fine. 2 to the 1/2. Can't calculate the exact value, so we don't use it. Fortunately, as I said before, we don't need it. This function is very easy to graph. You get a very smooth graph. Okay, if x equals 1, we're going to get 2 to the 1, which is 2. If x equals 2, we get 2 to the 2nd power, which we extend. That's 4. So there's our table. Now we have tables for both Toolkit reciprocal function, where we have to exclude 0 because it just doesn't exist. We have a table for our Toolkit exponential functions, where among the standard values, we don't include -1/2 or 1/2. not because they don't exist. They exist. We just can't calculate it. Okay, so let me make a note there. Both of these values exist. We just can't calculate them exactly, so we don't exclude them. The reason I choose to exclude them is because we want to have a visceral understanding what these numbers are. You can punch 2 to the 1/2 into your calculator, you're going to get 1.414 and then a bunch of other stuff. Okay? It's not exact. You don't know where it came from. You have no idea how it's calculated. You can verify it, you can square it, you can come out very close to 2. But you don't have any other visceral connection to it. You don't understand its calculation. You understand all of these calculations if you understand all the arithmetic of toolkit functions. And that arithmetic is fundamentally important for the entire pre-calculus course and on into calculus. Okay. So, important distinctions. This is undefined. It cannot be defined and be consistent with the rest of arithmetic, 1/0. No. 2 to the 1/2, yeah, it's defined. It exists. Proving that is well beyond any lower division undergraduate math course, first 2 years up through calculus and differential equations. You don't know enough to prove that it exists. Well, you kind of do once you get Taylor's series. That's a different story. Okay. It exists, but can't be calculated exactly. So we're not going to allow you to use it. You're not going to need it. Comes out beautifully. Okay, well, at this point, almost everybody can now go to a piece of paper. Take the interval from -2 to 2, split it in half and get 0. Split that in half and get -1. Split this in half and get 1. Split this and get -1/2. Split this and get 1/2. And right there's your x-axis. Then you can draw a y-axis here. And scale it accordingly. So for example, when x is negative, when x is 2, y is 4. Okay, so let's go ahead and put 4 up here. And draw the line y equals 4. And here we'll draw the line for x equals 2. X is 2 everywhere on this line, y is 4 everywhere on this line. To get this point, y has to be 4 and x has to be 2. Where does that happen? Well, it happens right there. There's a point on the graph. Okay. And we also have a point like 0, 1. Where's 0, 1? Well, x is 0, y is 1. So we've got to get y equals 1 in this graph. Okay, well, let's go ahead and divide the interval from 0 to 4 in half to get 2. Interval from 0 to 2 in half, we get 1. So here's where x is 0. Here's where y equals 1. And there's where the 2 lines cross. So this is a point on the graph. When x is 1, y equals 2. Well, okay, so here's y equals 2. Here's x equals 1, and right there's the point where x is 1 and y equals 2. There's 3 points on the graph. I didn't intend to do this whole thing, but it's so easy, I'm going to go ahead. Then when x equals -1, y is 1/2. Well, here's 1. We take the interval from 0 to 1 and cut it in half. And we have over here the line y equals 1/2. And here we have the line where x equals -1. So we have this point. And then we have y equals 1/4 when x equals -2. But 1/4 is half of a half. We can divide that in half, draw that line. Then we're going to get a point down here. We'll do this in detail later. And now we sketch the graph. That's a real easy graph to sketch. If you get it accurate, you're going to get a pretty accurate graph. And then you can even estimate what 2 to the 1/2 is. Okay, well, here's 1/2. And now we draw a horizontal line through this point, which is the x equals 1/2 point of the graph. And right there is our 1/4. It's between 1 and 2 and a little bit closer to 1. So 1.4 makes a whole lot of sense. Now we're not going to see 1.414 on this graph. It's not accurate enough. It's not big enough. But we can certainly see that it's very plausible that we get about 1.4 and we square 1.4. That's easy to square. We get 1.96. Real close to 2. So 1.4 is real close. 1.414 is much closer. But there it is. So that's where we're going to go.